We have a problem. The Sky Ranch is a supplier of aircraft parts. Included in stock are 7 altimeters that are correctly calibrated and 2 that are not. 3 altimeters are randomly selected without replacement. Let the random variable x represent the number that are not correctly calibrated. So that's important. Ones that are not correctly calibrated. We have 7 that are and 2 that are not. So altogether we have 9. So we're looking at 9 altimeters altogether. And we're looking for probabilities. Probability that that the random variable, which are not correctly calibrated, that none of them are, 1 are, out of 3, we're selecting 3, without replacement. So that's very important also. 2 and then 3. So let's look at the probability that none of the 3 altimeters that we're going to select are not calibrated correctly. Because remember, our random variables are that they are not correctly calibrated. So the quicker way is to look at the complement of that, which would mean that all of them are correctly calibrated, because the complement of all are correct or that none are correct. So we're going to look at the probability that none are correctly calibrated. And we're going to be selecting 3 altimeters without replacement. So let's think about that. So in that first selection, we have 9 altimeters altogether, and 7 are correctly. Now remember, we're looking for none, so we're going to say they all are good. It's just a quicker way to do it. All right, without replacement, so we're keeping that 1 out we just drew. And we had 7 out of 9 that were correct. So the next draw means I'm going to have 1 less, and 1 less that was correct. And then the third draw, again, we're keeping each one out, so we're going to go down 1 each time. Okay. So we got 7 out of 9 when we first draw, 6 out of 9, I'm sorry, 6 out of 8 on the second draw, and then 5 out of 7 in the third draw. So again, we're drawing 3 without replacement, so we're not putting them back. Okay, so let's calculate this. So using our calculator, I'll bring it up right here. So I'm going to do, let's do them all at once. 7 times 6 times 5 divided by 9 times 8 times 7 equals, and we get approximately 0.4166667. It says round to 4 decimal places. However, we need to be careful with our rounding because sometimes that will cause our answer maybe to be off just a little bit. So it's always good to wait till the end, but this is 0.4167. All right, now let's look at the next question. Now we're looking at the probability that we're still drawing 3. Okay, now we put all these back. We're going to look at the probability of getting 1 out of 3. So the probability of 1 that is not correctly calibrated. So if we're looking at the ones that are not correctly calibrated, so what's the probability of getting it on the first draw? Well, that would be 2 out of 9. Then on the second draw, the other 2 we draw, the second and third draw, those would have to be good if we want just 1. That is not correct. So we'll have 8 left, but this time we're looking at the correctly calibrated, 7 out of 8, and then we're going to be 6 out of 7. Now, something I want you to think about when we do this, we're looking at 1. Well, this was on the first draw. What if this one would have been a correct one, and then the second or third one would have been the not correctly calibrated. Or the first two could have been correctly calibrated and the second one not. So there's three different ways we can get one that is not just one, only one, that is not correctly calibrated. So we're going to multiply this times 3. Because again, we could look at this at, it could be, let's see, not calibrated correctly. And then the next two, not put plus there. Okay, so this is what we have right here. So the first one's not correct, the second and third are correct. Or we could have had this one correct and then this one not correct. Or it could have been correctly, and not correct. So you see we have three different ways these could be picked or drawn. We're still going to have 276 or 987. It's going to be that same number but 3 times. So I just want to make sure you see why it's times 3. All right, so let's look at this. Bring my calculator back up. And we're going to do 2 times 7 times 6 divided by 9 times 8 times 7. Oh, I forgot. Let me insert my parenthesis here. And then get that answer and multiply it times 3. So it looks like it is 0.5. So 0.5, and I'm just going to put zeros after it. Since it's rounded to 4 decimal places is what we're told to do. I'm going to skip to this last one for a minute, just because it's going to be pretty easy to find. So let's look at the probability of none. Oh, I'm sorry, we did that one already. Probability of 3 that are not correctly calibrated. Okay, exactly 3. This was exactly none, exactly 1, exactly 2, exactly 3. Well, that one's actually pretty easy to figure out. It's 0 because there are only 2 that are not correctly. There's no way I can get 3 of them that are not correctly calibrated. Now, I can work that out a little bit if you want to see exactly. Again, the first draw, you got 2 out of 9. Second draw, you have 1 out of 9. Well, the third draw, well, there's none left. 0 out of 8. We left it out. 0 out of 7. Okay. So it really doesn't matter because 0 times these is going to be 0 over whatever this is. Again, that really doesn't matter because 0 divided by any number, and we can just do 9 times 8 times 7, which is 504. But it's 0, so it really doesn't even matter what that number is. It's going to be 0 because there's no way of getting 3. It's just not possible. Now the reason I jumped down to that one because that makes the probability of 2 a lot easier to find because these should all add up to 1. So I can take these 2 and let's add them together and then we'll subtract it from 1. So the probability of 2 is going to be 1 minus 0.4167 plus 0.5, so 0.4167 plus 0.5, and then 1 minus that, looks like it's going to be 0.0833. And again, you just have to be careful for rounding. This one wasn't too bad. We really did not round up too much except for this one, but again, these should all equal 1, so it looks like we have 0.8333. So we have our probabilities, and we're going to need all of this to figure out our mean or our expected value. Okay, so let me see if I can give us a little more paper here. Move this up. Okay. So, to find the mean or expected value, So our mu, or expected value, adjust my camera here a little bit so we can try to see all of this as much as we can. Okay, so that's going to be each random variable. It's the sum of the random variables times the probability of each random variable. So 0 times 0.4167 plus 1 times 0.5 plus 2 times 0.8333 plus 3 times 0. Well, these both are 0. This is 0.5. That's 0. And then this is 2 times 0.8333. Just realize when I copied from here to here, that should be 0.08. So let's go back here. It should be 0.833, because that's going to make a difference down here when we find our expected value. So let's try this again. Okay, 2 times 0.0833, and it looks like I get 0.1666 plus 0.5 plus 0.5. So we're looking at approximately 0.6666. It says appropriate rounding. Rules apply. So that normally is we round to the nearest tenth. So we get 0.7. So again, I apologize. That should have been 0.0833 instead of 0.8333 on that question.